Hello everyone, this is for the solutions for the lesson 3 assignment, which was the first non-mandatory or graded assignment, but you should really look at it for practice. So I'm going to go through these questions and talk about how to do this is mostly about LOL diagrams, and using it in this way, actually let me show you how to set up the graphs. Especially for the quiz you're going to get, you are going to do the graphs like you do for this assignment. And also some of the required math, only like one problem, so I'll only go to like the OneNote thing for one problem. Okay. Lesson 3. All right, the first one says, an object starts with a potential energy of 1600 joules, okay? 1600 to 238 joules. It begins moving and ends up with only kinetic energy at the end. What should be the value for this kinetic energy? So this question is a practice just of knowing your understanding of conservation of energy. Remember, conservation energy says whatever's in the beginning equals the end. So I'll show you that. So if there's only potential energy in the beginning, 16,238, that has to be the amount of kinetic energy at the end. That's what I wrote down here. If P started with an energy of 16,238 joules and energy is conserved, that means the kinetic energy must have the same energy once converted, which means it's also 16,238. That's all I should do for number 1. Just saying it must be 16,238 because energy is conserved. Number 2, this was a little bit of math. So I gave you a set of energies, and there's an initial case and a final case. You know which one's initial based on the last letter, K-E-I, I, initial, F, final. So the final potential energy is unknown. I gave the other ones. So using the conservation of energy, how would you calculate it? So let me set this up. All right. Where is it? We have KEI equals 20 kilojoules. PEI equals 30, I believe. Or let me double check this. 20, 35, 15. Sorry about that. And the initial thermal energy is 15. Sorry about this. Let me just check something. Then I gave you KEF was 7 kilojoules. PEF, we don't know. And TEF was 13. So remember conservation of energy? I gave that to you in the video or in the notes in the form of the equation. Once I this. So EI equals EF. That means the total energy in the initial case equals the total the final energy in the initial case. So what's the total energy in the initial case? You just add all those numbers. So EI is 20. Oops. Plus 35 plus 15, which is 70. What is EF? We have 7 plus PEF, which we don't know, plus 13. So now you just want to set these two equal to each other. Remember, whatever the total is in this side equals the total on this side. So 70 kilojoules must equal 7 plus 13 plus whatever PEF is. So 70, when you add these two, you get 20 plus PEF. Let me do this with a different color so you can visualize this. This is just basic algebra now. You're just going to subtract to both sides, 20. And you put your final answers. 20 minus 20, that cancels out. And 70 minus 20, that's 50. Equals PEF. That's it. That's the only thing we solved for. So the final potential energy will have to be 50 kilojoules. And that makes sense because if you put 50 here, you add these up, 7 plus 50 is 57, plus 13 is 70. So that matches up with this side. Okay, that's what I have to do for number 2. Ooh, what's getting really bright in my camera? Number 3. So below is the energy of initial cases system. The final potential energy is 0 kilojoules, and the final thermal energy is 600 kilojoules. Move the chart for kinetic energy to make sure energy is conserved. Okay. Now here's the thing. This is the initial case. So we have 600 kilojoules. Yeah, we have 600 kilojoules for potential energy. Actually, this is the final answer. I think I originally started this, but I actually already put the answer for this. Oh, wait. Give me a minute. All right, sorry about that. I was using an old version of that assessment, but I fixed these in the ones you have right now. So sorry about that again. So we have the initial case right here. Potential energy and thermal energy. You have potential energy in 700, thermal energy in 300. That means that the total energy will be 700 plus 300, 1,000. If that's the case, then if the final thermal energy has the final thermal energy is 600 kilojoules, first let's just put that. You can just drag it here. All right. And then the final potential energy is 0. So this should be down here, 0. So now we need to make sure energy is conserved. If there was 1,000 total, and then now there's 600 thermal energy, how much kinetic energy must there be for the total to be 1,000? Well, 1,000 minus 600 is just 400, so you just drag it up to 400. So that's it. That's how you set up a graph. I also set up the graph so that there's some leniency because I don't expect you to go directly on the line, and there might be some mistakes, like you put it a little bit up, a little bit down. So I gave some leniency, so if you're like a few points off, it'll still count as right. All right. Lesson 3, number 4, you have this scenario. You have a little toy cart that's getting ready to be propelled by a spring. There is friction on a track. There's friction on a track. The spring's potential energy is originally 1,000, so 1,000 joules originally at this point, at point A. Which of the following LL diagrams correctly label this scenario, assuming the system is the cart, the track, the spring, and the earth? So we need these 4 things in our system, and then we got to make sure the LL diagrams follow this scenario. Explain why you chose your answer using the evidence from the options below. And then, so each of these graphs have an option for kinetic energy, gravitational potential energy, spring potential energy, and thermal energy. So let's take a look at these graphs. Let's take a look at A. For A, we have, well, for all of them, the initial cases are all the same thing. We have PES at 1,000. Take a look at that. A has PES initial at 1,000, then around here, like a third for each, for kinetic energy, potential energy, and thermal. But And then they have the cart, track, and spring for the system. Remember, L is the first initial case, the O is the system, and the last L is the final case. This doesn't have everything in the system. You're missing the earth, so it can't be A. B, again, the same thing for initial case. This time we have the earth, so that's looking good. But there's KEF, PEF, and nothing else. Remember, there is friction, so that means there has to be thermal energy. Friction causes heat, produces heat, which produces thermal energy, so it can't be B. C has all of that, the system, and also the three different things, so it has to be C. So the correct LL diagram is C, because it contains all the parts of the system: the cart, the track, the spring, and the earth. And it has thermal energy in the final case. Which is caused by friction. A and B, we're missing at least one of these. There. A and B, we're missing at least one of these, and that's why those can't be the right answer. Right. So that's what you put for 4. Now let's go up to 5. So these are the same scenario. Okay. So we have this roller coaster at point A is up here, point B is down here. We're assuming that the initial total energy is 3,500 kilojoules. And how would you set up the initial LOL diagram? So, and there's no friction. So that means there's no thermal energy. So I gave you the initial kinetic energy and initial potential energy. We're assuming that it's not moving on the top. We're just about to start moving. So if that's the case, there's no kinetic energy. And now it says there's a total energy of 3,500 kilojoules and there's only potential energy, then that means you have to put that at 3,500. Because that's the only energy that you can have. So that's all you have to do there. All right. List the parts, the major parts of the system and explain the role. So what goes into the O of the LOL diagram? So you could go to the previous questions, just as end notes and your notes to see through it. So we have the Earth, of course, which causes the gravity. It causes the gravity for the cart to move, the cart of the roller coaster. All right, let me zoom into this so you can see it more. Then we have the cart itself. I'll fix that notification by next video. That's the object we're talking about. That's the main thing that's moving. You have the tracks. I think it's the tracks because that's basically, that is the path. That provides the path of movement. Getting laggy. That provides the path of movement. So the Earth, because it causes gravity, the cart on a roller coaster, and then the tracks of the roller coaster, because that causes the movement. All right. 7 is similar. The following scenario is what you'll answer. So this time, if the total initial energy is 3,500 kilojoules, how would you set up the last part of the LOL diagram? So we're at the very bottom now, point B. So at this point, that means kinetic energy, the potential energy will be 0. And since there's only one 3,500 kilojoules and energy is conserved, that means this kinetic energy needs to go here. Remember that again? The potential energy was converted completely into kinetic energy. Whatever happens first for total energy is the same total energy at the end, no matter what. And since we only have kinetic energy here, that has to be 3,500. Right. So that's it for lesson 3. Now I'm going to go over lesson 4 in the next video. All right, thank you.